Hello students, this is next video of chapter motion. In this video, I will discuss about graphical representation of motion. But before going to discuss, you must know there are some physical quantities that are used in chapter motion. First physical quantity, distance, second displacement, speed, velocity and acceleration. There are some symbols that we will use for these physical quantities. First is distance. Distance is represented by S letter or X. Displacement is also represented by S or X. Speed is represented by V. Velocity is also by V letter. Acceleration is represented by small a. Now, as we know that there are some symbols as well as units is also there. Distance is represented in meters. Displacement unit, SI unit of displacement is meter. SI unit of speed is meter per second. Velocity is also meter per second. SI unit of acceleration is meter per second square. Now there may be of two types of motion. Uniform motion and non-uniform motion. Uniform motion and non-uniform motion. Uniform motion means equal change in distance with equal change in time. It means in uniform motion speed will be constant. Speed will be constant because equal distance is changing in equal interval of time. If speed is constant, that is acceleration will be 0 for uniform motion. Now in case of non-uniform motion, speed will be variable because in non-uniform motion unequal distance changes in equal interval of time, so speed will also be changing. Hence if speed is changing, then there may be acceleration, or we can say acceleration is not 0. So in uniform motion acceleration will be 0, and in case of non-uniform motion acceleration will not be 0. Now I am starting your next topic, that is graphical representation of motion. There are two types of graph in motion. First is distance time graph, that is ST graph. Second is velocity time graph, or you can say VT graph. In distance time graph there may be further two cases, uniform motion and for non-uniform motion. Uniform motion means this is x-axis, y-axis, and on x-axis time is there, y-axis distance in kilometer, time on x-axis in minutes. Because of its uniform motion, there will be a straight line because there are 2 points A and B. At A point, distance covered by the body is S1 at time t1. At B point, distance covered by the body is S2 at time t2. So ST graph gives a straight line for uniform motion. If ST graph having a straight line, because this is a distance time graph, equal distance cover in equal interval of time, so it may be uniform speed. So from this figure, from this graph, A to B, speed will be s2 minus s1 upon t2 minus t1, because the distance covered in between A and B, s1 to s2 time t1 to t2, s2 minus s1 total distance upon t2 minus t1 total time. In case of non-uniform motion, distance is changing non-uniformly. It is not a straight line graph. At you can see at this point distance is s1, you can take s1 time t1, but at for next point distance is not a changing uniformly. This is next point, it is not changing uniformly, or you can see the graph, the distance between the 2 points from here to here, first and second point, it is also not a equal change. Now next graph is velocity time graph, that is VT graph. There may be of two types, uniform motion and non-uniform motion. As you can see, uniform motion, first is if velocity is uniform, if there is an object, it is moving with uniform velocity, then we can plot a graph between velocity and time. At t1 point velocity is v. At point A, at time t1 velocity is v, and at B point velocity is also v, but time is t2. Velocity in this graph it remains same. Here velocity is not changing, so the area under this line gives displacement, because displacement equal to velocity into time. Velocity is not changing, velocity at A point is v, at B point is also v, but time is changing t1 to t2, so displacement will be velocity into time, that is change in time, that is t2 minus t1. In case of non-uniform motion, velocity time graph, firstly velocity is increases, then decreases, increases, decreases. It means velocity is sometime velocity is increases, decreases. In non-uniform motion, velocity is changing non-uniformly with time. So this type of motion is non-uniform motion. If we are plotting the graph for uniformly accelerated motion, uniformly accelerated motion means velocity time graph is also there. Again, this is a straight line. Uniformly accelerated motion means equal change in velocity in equal change in time, then graph will be a straight line. Now we can take 2 points A and E. At point A, suppose time is t1. At point E, suppose time is t2. At A point velocity you can take v1, at E point velocity you can take v2, but there may be an equal change. That's why this graph is known as uniformly accelerated motion, and that is straight line. Velocity time graph for uniformly accelerated motion, in will be a straight line. Now area under this this 2 points AE, we can take the figure A B C D E. What is the area under these 2 points? It will be written as area under ABCDE gives distance, and distance is represented by S equal to area. As you can see from this, there is one triangle, other is rectangle. First triangle is AED, second rectangle is ABCD. So calculate area of triangle plus area of rectangle. This will give the area under these 2 points A and E. S equal to area of rectangle plus area of rectangle, length into breadth plus area of triangle half into base into height. This formula gives the distance covered by the body between 2 points AE. In this chapter, there are 3 equations of motion. First, velocity time relation. Second, position time relation. Third, position velocity relation. First, velocity time relation, second, position time relation, or ST relation. Third, position velocity relation. VT relation, ST relation, SV relation. VT relation is V equal to U plus AT. ST relation is S equal to UT plus half AT square. S equal to UT plus half AT square. Third, position velocity relation, V square minus U square equal to 2AS. V square minus U square equal to 2AS, where U is initial velocity of the body, V is final velocity of the body, T is time, A is acceleration, S is position or distance or displacement. Here in this relation, S represents position, U initial velocity. As you can see, there are 3 equations of motion that we will prove now from graphical method: position time relation, velocity time relation, position velocity relation. Now take velocity time graph. Suppose an object is moving having some initial velocity u at point A and final velocity v at point B. The time taken by the object between A and B is t. This is u, initial velocity, final velocity. Now we can slope of line AB from this graph, we can find the slope of this straight line by taking a triangle ADB. slope of this line AB is given by, in this triangle, perpendicular upon base. Perpendicular is BD, base upon AD. Perpendicular upon base, perpendicular BD, base AD, BD upon AD. What is the value of BD? BC is V and OA is parallel to CD. That means CD is also U. BC V, CD U, BD will be BC minus CD. BC is V, V minus U, then BD will be V minus U. Put this value of BD here, perpendicular upon base, perpendicular, BD base AD, BD V minus U, base, this is parallel to OC, AD is parallel to OC, OC is T, that means AD is also T, BD V minus U, AD T, V minus U upon A, V minus U upon T equal to A. Now V minus U equal to AT, V equal to U plus AT. This is the velocity time relation. Next is position time relation. Position time relation is given by area under this line, area under straight line AB, this area we have to calculate, because we know that area under velocity time graph gives displacement, velocity time graph gives displacement. So area under this line OABC, this is the shape of trapezium and it is the combination of triangle plus rectangle. First calculate the area of triangle, then calculate the area of rectangle and put the values. Now S equal to area of rectangle, rectangle is OADC, plus area of triangle ABD, rectangle length into breadth, area plus area of triangle half into base into height. By putting the value, what is OA? What is OAU? OC T, OC is T, plus half AD, AD is parallel to OC, that is T, T, BD, BD is V minus U. Put all this value here, then you will get S equal to UT plus half T into V minus U. Now V minus U from equation 1 we can calculate. Did V minus U equal to 80? Put this value of V minus U here. V minus U, that is 80 into T, half AT square, that is S equal to UT plus half AT square. Now last relation is position velocity relation. Now we have to prove V square minus U square equal to 2AS. As we know that area of OABC is the shape of trapezium. Now put the formula of area of trapezium, half into sum of parallel sides. As you can see from this figure, OA is parallel to BC, OA is parallel to BC, half sum of parallel sides, that is half into OA plus BC, half OA plus BC into height is OC, OAU BC V OC T. Now put the value of T from this relation. Find the value of T from here. T will be V minus U upon A equal to T. T will be v minus u upon a equal to t. Now put this value of t here. T will be v minus u upon a. Now use formula of a plus b into a minus b. This is a plus b into a minus b. A square minus b square upon 2a. 2a will go here. Then 2a s equal to v square minus u square. This is third equation of motion. Now there is one example on the basis of these relations. Question is, a bus starting from rest moves with uniform acceleration 0.1 meter per second square for 2 minutes. Find speed and distance. As bus is starting from rest, then initial speed is 0, acceleration is given, time is 2 minutes, that is converted into minutes to second, 120 second. Find the speed. Use this formula v equal to u plus at, because time is given, acceleration is given, initial speed is given. Calculate v. Similarly, we can find the distance. We have two formulas of distance, second and third relation, but time is given, so we will use this s formula. S equal to ut plus half at square. Use 0, then it will become 0. Half a 0.1 meter per second, then that is 1 by 10, time 120 second, t ka square, then s equal to this, s 20 meter. Now next topic is uniform circular motion. Uniform circular motion means when object is moving in a circular path with constant speed. The object is moving in a circular path but with constant speed. This is known as uniform circular motion. For example, a satellite moves in a circular path around the earth. Speed is constant, but uniform circular motion is an accelerated motion, because in case of circular motion, direction is changing continuously at each point. You can see from this figure, object is moving in a circular path. At a point, direction of velocity is this, B point here, C point here. So you can see velocity, the direction is changing at each point on the circle. If direction is changing, it means velocity is there. So direction is changing at each point. Direction is changing, that is velocity is changing. If velocity changes at each point, it means this type of motion is accelerated motion. So when an object is moving in a circular path, it is an accelerated motion. The speed in a circular path is given by distance upon time. Distance for a circular motion, distance is in terms of circumference of the circle, that is 2 pi r upon t. Speed equal to distance upon time, distance 2 pi r upon t. Now on the basis of uniform circular motion, we can calculate speed if object is moving in a circular path. A question is there, an artificial satellite is moving in a circular orbit of radius is this. Calculate speed when time is given. Time, radius is given, time is also given. Speed equal to distance upon time 2 pi r upon t. Put this value and find the speed of the satellite. Okay.